question, write an ALP to find smallest of 16 numbers stored in a RAM array starting from internal RAM location 30H. This is my question. Okay, so let us try to do this program. Okay, listen. First, you have to code your question. Question is to be converted to microcontroller code. So, what is your question? There are 16 numbers. So, 16 means it is decimal. You have to convert to hexadecimal. So, 16 is what? 16 is what? In hexadecimal, A is equivalent to 10 in decimal. B 11, C 12, D 13, E 14, F 15, 10 is 16. Correct. So 10 is 16. I hope you understood. So you have to write move. Don't write R0 R1 because it may be used for pointing. Move R2 comma hash. There are 16. So 15 is F 0F. 16 is next number, means 10H. Okay. So this is the count. There are 16 numbers. Then they have mentioned that the numbers are in internal RAM location starting from 30H. So you have to point it as an array. So pointing of internal RAM is done by either R0 or R1. So move R0 comma hash 30H. This is done. That means we have converted your question to microcontroller code. Now you have to assume that always smallest number is in A, accumulator. So let us assume that smallest number will always stay in accumulator A. So what you have to do now? First you have to compare two numbers and thereafter you are comparing only one number with the smallest number. First you are taking two numbers and finding smallest. Next onwards you will be comparing only one. So there is a mismatch. First two data and next onwards one data. So to avoid that, what I will do is every time I want to compare one data, I will initially assume the smallest number, which is wrong. That means I will always assume the largest number as smallest so that other numbers will not get affected. Correct. So largest FF if we take, nothing will be, larger than FF. So whatever number you are having, you will get smallest out of that. So comparing with FF, if the other number is 0, 1, smallest will be 0, 1. So it will not affect the result. Understood now? So what I will do is, I will assume initially the largest number as smallest. Always you have to do like that. You have to assume largest number as smallest. So move A comma hash FH. So when F comes, you put 0 first. A, B, C, D, E, F comes, put 0 before that. So you are assuming that accumulator contains smallest. Initially, FF, largest number you have to assume so that it will not affect your other smallest number. This is okay. Clear? Clear or not?
Yes, sir.
Yes. Now, I have to take this first number. So, first number is in 30. Instead of 30, I have put it to R0. I can call it as at R0. At R0 means content of R0. Content of R0 is 30. Content of R0 means content of 30. That means first number. So that number is pointed by at R0. So at R0 if you mention, I will get the content of 30 means first number. You take it to some arbitrary memory location. Why you know? Because you have already used you have already used accumulator. So don't take to accumulator. And remember, I am going to use CJN instruction. CJNE, if I write A, comma, what are the addressing modes available? At R0 is not available, R0 is not available. I can have only option CJNE A, comma, one address I have to write. So you take an internal RAM address which will not affect any of other things. So your data is present from 16 data are there, 3031 like that. Anyway, it will not reach 50H. So I will simply take some memory location which will not affect what we have written before. You should not write 02, then it will affect 02, R2. You should not take 00. You know that R0 is 00 location of internal RAM, so it will affect R0, so you should not write R0. And you should not take any number. 30 you should not write because it contains data. 31 you should not write. So 16 locations from 30 you are not supposed to write. Anyway, 50 is far away from that. So you are taken your first number to 50. Now, smallest number is in A and your first number is in location, internal RAM location 50H. Now I will compare between them. CJNE, compare and jump on not equal. A with A, I cannot write at R0. That is why I did all this, one extra step. I could, if there was an instruction allowing to write at R0, all this problem would not have been there. But I cannot write at R0. That's why I moved to 50 only for writing this 50H. 50H. Fine? 50H. So what it does, it compares and jump on not equal. My question is not to check whether they are equal or not equal. My intention is to check whether which is less, whether out of two things, one in A and another in memory location 50, which is smallest I have to find. I am not bothered whether they are equal or not equal. So equal or not equal doesn't matter for me. I am doing this instruction just to compare. I will not get anything if I know whether equal or not equal. So I will not use this instruction further. That means what I will do is whether they are equal or not equal, same condition. So I will not go forward with this instruction based on checking. So I will terminate this equal not equal checking immediately by writing next step itself, loop 1. That means what? When they are not equal, it goes to loop 1 next instruction. If they are equal also, it goes to next instruction. That means equal not equal checking is not done. I hope it is clear. Clear now? This much is clear now? Now I want to check whether A is smallest or 50 is smallest. Content in 50 is smallest. Content of 50 is smallest. A is smallest, I am happy. I can go to the next number and check. So A is smallest means I am happy. I can skip. I don't have to do anything. I can go to the next number. When A is smallest, what will happen? No, it is like doing A minus content of 50. So A is smallest means smallest minus larger will give a carry. So jump on carry, I will call it as loop 2. You understood? My intention is to keep smallest number in accumulator. So already if smallest number is in accumulator, I can go to the next number. Okay. So smallest number in accumulator means it is doing A minus content of 50. Smallest is A means it will generate a carry. Smallest minus content of largest will generate a carry. So if carry is there means A is smallest. I am happy with that. I can go to the next number. Next number is in where? 31. So R0 is 30. So INC R0. INC R0. Now here means opposite condition. Opposite condition means A is not containing smallest, 50 is containing smallest. So you have to move, because smallest always should be an accumulator, but unfortunately it is in 50H. So that content has to be moved to A and go to the next number. Go to the next number. So while going to the next number, it is only going to the next number, not number is not taken. So one number is over now. So DJNZ R2, one number is over, back. So this back goes to taking that next number to 50 for comparison. That means when you are using my method, always back will be first instruction after all hash. Here hash no, here hash no, here hash no, here no hash. So there you write back. So your A is containing the smallest number. Now if the question, if they ask smallest number to be saved to some 60 location, here you can write move 60H comma A. I hope you understood. Clear or not? Is it clear? Is it clear? Is it clear?
Yes, sir.
Oh. Do it. Do it faster.